Welcome to Part 5 of Competency 4. In this video, we will work with geometric series. Notice that we have two formulas for the geometric series. One is finite and one is infinite. The finite series is for when we want just a certain portion, a partial sum, just as before. But for the infinite geometric series, we have a situation where we can ask what is the sum of all the values. However, that is reserved only for the infinite geometric series where the ratio, the absolute value of the ratio is less than 1. Number 1, what is the sum of the first 24 terms of the sequence 2, 8, 32, 128? Okay, we know that ace of 1 equals 2, and our common ratio is 4 because 8 divided by 2 is 4, 32 divided by 8 is 4. Okay, now we have been given a formula that we can use because this wouldn't be infinite, it would be finite. And not only that, our ratio is obviously greater than 1. So we have to use this particular formula, which by coincidence is up here. And we can put that, it's right here, here, from our example. Okay, so let's put that in our calculator. Y equals, so let's say alpha, y equals, we want number 1, and then we have 2 minus 2, parentheses, 4, close parentheses, caret up, and push your x. Now remember, the x is in because we're still in sequence mode. Okay, let's arrow down, and then that is 1 minus 4. Now I'm entering everything exactly the way we see it. Okay, so what do we need? We need to look at 24. So let's go to the window, second window, which gives us our table setup. I'm going to go ahead and put it at 4, and it's probably best to go by steps of 1. So second graph. And what do we want? Oh, 24, and I put 4. Well, let's go back and do it correctly then. 24. No, that's a 7. There we go. Finally, I'm going to push enter, give it a second, and then push second graph. Okay, now, looks like we have a rounding situation. Well, A and B say 1.90. Okay. But 1.88 could be rounded to 1.9. A and B have the wrong exponent, and I'll tell you how I know. That is because we're given the exponent in our answer. This is actually the notation that would be 10 to the 14. So this is incorrect, this is incorrect, C is incorrect, and D actually is correct. It's just that the calculator can only do so much. It only has so much space and it's programmed a certain way. What is the sum of the first 15 terms of the sequence 90, negative 30, 10, and negative 10 over 3? Okay, first we identify that ace of 1 equals the 90, and our ratio equals negative 30 over the 90, which equals negative 1/3. Okay, so let's put in our formula, and we need to make sure that we deal with our positives and negatives correctly. Okay, so let's do y equals, and let's say alpha, y1, enter. Okay, we have 90 minus 90 in parentheses. That's going to be a negative. Now we have alpha, okay, alpha, y equals, and then enter. Now, see how my negative is staying with my 1/3. I'm going to put 1/3. Make sure that you are aware of how this works. Now, I don't want to close my parentheses yet because of the way things will pop around. What I'm going to do is say caret up and then N, and then I'm going to scoot over and close my parentheses. Now I'm going to arrow down and make sure that that is working the way that it should. Okay. Now I'm going to say 1 minus, and I have my parentheses. I'm going to use a negative, and then alpha when y equals, and then, okay, now see how you can't see that fraction? Don't worry about it. Put in your 1 and then arrow down and it pops up for you. And then I have the 3, arrow all the way over. Okay, now this can be a little testy because of the parentheses and the negatives, because we're mixing a negative in front of the fraction and then I'm using a minus sign. And then when we have the exponential, that to the nth power. Oh, see what it did? It popped over. That isn't going to work. That's what happened to me earlier. Be very aware of this. Okay, what you have to do is see that negative, delete it, go to the inside, and now enter your negative, okay? And this should work. You've got to make sure that the negative is included inside that parentheses, okay? Right, because you're using, it's got to be the whole thing. I know, I kind of had a little touch and go with it, but R is the entire expression, -1/3, okay? And you have to put the whole thing to the nth, okay? All right, that all being said, let's see if we can get it to work. Let's push second graph. Oh, amazing. There it goes. And that actually, even though it looks like it isn't correct, it is. And we want the 15th term. And when we arrow, see how it changes? Because of rounding, it just kind of rounds, it stays there. It's just a weird situation. However, that doesn't matter. We have verified that the answer is B. And I've also solved this by hand, so we are correct. All right, number 3. What is the sum of all of the terms of the infinite series? 60, 15, 15/4, and 15/16. Okay, the first thing that we need to note is that we need to have the absolute value of R less than 1. Well, that's true because R is going to equal 15/60, and that actually does reduce to 1/4. And the absolute value of that, regardless, is less than 1. Okay. Now, we are going to use a different equation for this because it says all. We check that our R is within the parameters that we need, and we want the sum of everything. Okay. So what do we need to do? We need to put in our calculator. We can just like solve that quickly. We need 1. Oh, ace of 1. No. Ace of 1. Sorry. We need ace of 1, which is our 60, and then 1 minus 1/4. And that should get it. So let's back out here and just pop it in the calculator and see what happens. Okay, alpha y equals, right, there we go. So we have 60, arrow down, 1 minus alpha y equals, that's 1/4. Push enter, let's see what happens. And it's 80, and that's actually correct. There we go. All right. Now let's look at number 4. We saw 4 and 5. Okay. Number 4, the sum of all the terms of an infinite geometric sequence is negative 4 over 9. Okay, so we're going to use the prior formula, and let me just quickly set it up. Okay, that's negative 4 over 9. And now that's going to equal, let's see what we have. If the common ratio is negative a half, what is the value of the first term, a sub 1? So we have a sub 1, that's a I don't know, and then 1 minus a negative half. All right, let's just put that in our solver. But before we can use a solver, we have to change our mode. So get out of this, and let's highlight function. You want to be in function mode again, and back out. Now let's use math, arrow up. We're going to use numeric solver. Clear that, and we need negative. This time, I'm just going to do 4 divided by 9. I've been putting in fractions a lot, but we don't have to do that if it's a simple situation. All right, I'm going to enter. Now I'm going to clear everything out. But now, just for safety's sake, let's put in that fraction, okay? And our a sub 1 is going to have to equal x. And we can do that because that's the only variable in the entire equality that we have, so it's safe. Okay, so we have 1 minus parentheses, and I'm going to say negative 1 divided by 2, close my parentheses, and I'm going to pop over. And remember, we're going to have to push graph twice to get the answer. So let's push it once. Okay, see what we get. Push it again. And we know that this is a valid answer because we have this second bullet. Now let's look at, that is, the x value really is negative 6 repeating is negative 2/3. And that is option A. Yes, that's the only one that works. Yeah. Okay. Now let's look at number 5. This looks like it's going to be a little different. Okay, we have 2 ways of dealing with this. Okay, we can put this within sequence mode and put it in the way we've been using so far, what we've been using so far with our y equals, okay? And we could subtract the 10th value, actually minus the 4th, okay? So we can take the 10th value, add it all up, and then minus out everything from 1 to 4, and we'll get the value we need. Or we can use summation, okay? And we can actually, I think setting up, if we set up summation, the glitch is that we would have this, okay? And it says 5 to 10, all right? But we'd have to use a different equation. We would have to use that original geometric, which is actually, no, not the, we would actually have to get the actual values. No, it would have to be 2 times r, which would be 4, and then n minus 1. Okay, let's see what happens. Let's see which one works, all right? All right, let's go second mode, all right? And we need to go back to the geometric series. I'm going to push enter, back out, y equals, clear everything out, and let's say 2 times 4, carry it up to the n minus 1. Okay, and now I'm going to back all the way out. I'm going to say alpha window and go to number 2. That's your summation. And then n and I need 5, and now I'm going to go up to 10, and now I want to pull that equation and use it. Okay, so I push alpha trace number 1, and let's push enter. And that's actually the correct answer. Okay, yes. What the difference is, look at how I had to use this prior equation or a prior formula. Let me write this. Remember, that's our rate. Okay, I'm not sure why it's not. It's not. Oh, there it goes. There it goes. Sometimes it takes a second. All right. So remember, this is how you got a an geometric series, right? When we found out what the number was. So that's what we did. We said, okay, here's our numbers. Now we need to add those numbers up. Well, let's try it the other way also, but we'll have to have the other formula. Okay, the other situation. Okay, so let's go to y equals. Let's clear everything out. And remember, we have to have that fractional set up. Okay, so it's going to be 2 minus 2. All right, I'm going to do parentheses. And we have 4. 4. And then carry up to the end, move over, close it. And then we're going to go down and say 1 minus the 4. All right. Now we want to go from 5 to 10. Let's see what our window's in. Our window's okay. So let's go second graph. Okay. And I'm just going to arrow. Okay. Yep, that's what we have. Okay, now we said we needed to do 10 minus 4. But notice this is really what we're going to have. 10 is actually 6, 9, 9, 0, 5, 0. And then that is going to be minus 170. Okay. And if you can't tell, that's actually 9. All right. So just to verify, oh my goodness, can't even tell that's a 9. I don't know about my handwriting. That's a little better. Okay. Let's just pop that in the calculator. So second mode, and let's see, 699,050 minus 170. Double check I have it entered correctly and push enter, and we should have the same value. And yes, we do. So that is 2 ways to sum up uh, values that, let's say, are somewhere in the middle of your sequence. Okay, that's the end of this video. Thank you so much for watching. I hope this is beneficial, and thank you for putting up with my handwriting. It's greatly appreciated. And thank you for subscribing and liking and sharing us and making it all the way to the video. You guys are the best. Happy testing.